Hey! Wow, we got it. So a couple things, and actually what I want you to see. That is what I want you to see. A couple things we're going to do today. So yesterday I had you go through and I had you look at position versus time graphs. The position versus time graph. There's a series of questions for you to answer based upon like how the graph moves, how it curves, is it straight, is it not straight, is it a positive slope, is it a negative slope. We can draw some conclusions from that. Just to make sure we're clear. The slope of the position versus time graph, or distance displacement versus time graph, the slope gives us velocity. A positive velocity means nothing more than it's moving in the positive direction. A negative velocity means it's moving in the negative velocity. Sorry, the negative direction. A negative velocity doesn't mean it's moving faster or slower. A negative velocity doesn't mean it's going backwards. I can walk in the negative direction while facing forwards. Okay, a negative velocity tells me the direction, and if we're talking about left and right, it's to the left. If we're talking about up and down, it's going to be down. That's all a negative velocity means. So in any of these graphs where we have a negative slope, it means it's moving in the negative position. It means it's moving in the negative position. Anything that has a positive slope means it's moving in a positive direction, and anything that has no slope means it's not moving at all. Okay, no slope means no velocity. So that's what I want to make sure we're clear on. There's a sheet that you picked up called Position versus Time Graph Conclusions. And what I want, and it's two-sided, but we're only going to deal with the position versus time graph right now because that's all we've talked about. Looks something like this. It's written as like an if-then kind of format. So if my velocity is 0, then I'm looking for a line that is blank, and it might look like blank. So like straight, curve, flat. And then we'll kind of draw some examples. There are intentionally these big, bold lines between certain sections because it's going to be one of these three. It's going to be either 0, positive, or negative. Then there's a couple more. There's two questions. Is it constant or is it changing? It's going to be one of these two statements. Then acceleration is 0, not 0, and then it's speeding up, slowing down, or the object speed is the same. So my intention is for you to go through and to take a little bit of time to look back through your question sheets or start over from scratch. And I would encourage you on these graphs to go through. We're looking for trends. Okay, that's my intent, is we're going to look for some trends. So we're going to kind of draw some conclusions on these things. So, like for example, if I'm looking at motion graph number 1, given the choice A, velocity is 0, B, the velocity is positive, or C, the velocity is negative, what is this one? Remember, the slope tells me velocity, so is it positive slope or negative slope? Positive slope, so therefore, this would be, given the choice between A, B, and C, this is a B. Okay, then I would look at this one. Is this an A, a B, or a C? B. Okay, and then we could say, well, is this one an A, B, or a C? And you could say, well, that's a C, that's a negative slope. And my hope is by doing this, it'll very kind of force you to kind of think about, draw some conclusions, and say, hey, these are what they look like, these are what I'm looking for. I'm looking for a line that is going up to the right, going down to the left, is horizontal, is flat, has no slope. Okay? So, last year I went through and I wrote down all these with them. I don't know if I want to go through and talk through everything with you. I do want to make sure we're good and we have the right conclusions drawn. So I'm going to kind of get a feel for where you're at in a little bit. I don't mind if you say, hey, can we work with this on someone? That's fine. But when you're done with this, you should have you should have 4 letters next to each, like in each box. I don't care if you put it here, 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 I don't really care. You should have an A, a B, or a C. You should have a D or an E. You should have an F or a G, and then you should have an H, an I, or a J. So there should be 4 letters next to each one. Okay, that's the idea. From there, what am I looking for? Okay, then that second column. So if my velocity is 0, I'm looking for a line that is, look at all the things that have the letter A next to it. What general trends do you see about all your ones with the letter A? What general trends, what does the line physically look like that has all the B's next to it and then all the C's? The last column in the past, I had gone through and I had drawn like a bunch of like mini graphs in those and like, oh, it might look like this, or it might look like this, or it might look like this. That's where I'll kind of say, let's see. Okay, so I want to give you a little bit of time to go through all those 9 graphs. You should have 4 letters kind of next to each one. And then we should be able to talk kind of through some of these general conclusions as a class. Okay, that's what I want you to do. We'll come back in a couple minutes. Up on the screen, just for the record, this is kind of what I had last year, just to kind of get you kind of thinking about what I'm looking for. You know, things where like my velocity is 0. What are we looking for? We're looking for a horizontal line. We're looking for something that has a slope of 0 or flat. Those are all different ways to say the same thing, right? A flat line, slope of 0, a horizontal line. Okay, and this is what I was saying visually. I don't know, maybe we will, maybe we won't talk about it. But like quick sketches, like what does my graph look like? Well, it looks flat. I screwed up, there was whiteout tape that I used, but it should be flat. Positive velocity means the graph is going up, or it has a positive slope. Now there's 3 different graphs that you have on your paper that have a positive slope, right? A straight line up, a curved line up, and a curved line up. Now I'm not going to claim, I don't remember from whatever math class I took that talked about concavity. These have different concavities, and I don't know, and I'll be honest, I don't care for us. This is a positive slope, this is a positive slope. Those are the kind of things I want you kind of looking for and seeing. And we'll talk about a few of these in a little bit, but that's kind of some of the conclusions. This is kind of to give you an example of what I'm kind of looking for. All right, so just so I'll tell you, this is in today's agenda. The video that I'm recording right now, fingers crossed that I can take it off that camera and put it on YouTube, is going to get linked right here and embedded right here. Also directly below that is a copy of this sheet filled in that we're going to go through kind of quickly. My intent is to do it fairly quickly. These are some general trends that I was hoping you were able to gather based upon putting those letters next to it. So the only graph that had the letter A next to it was graph number, I believe it was 5. Correct me if I'm wrong, 5. Okay, it was a flat line. However you want to describe it, that's kind of what that's meant for. How would you describe it? Would you call it flat, a slope of 0, a horizontal line? I don't care. It would look something like that. Really quick sketch, that was my intention there, just so, hey, that's what I'm looking for. You should have hopefully figured out that all of these graphs that were like this have a positive slope, which means they're heading in the positive direction, or the positive direction. Okay, we're talking mostly in the x direction right now. Even though this is a curved line, it's curving in the it's got a positive slope. This is a curved line, positive slope. It goes up is sometimes how people describe a positive slope, versus it goes downward. Okay, it's going up versus it's going down. The difference between graph number 1 and graph number 2 was nothing in terms of the questions that I asked you. The only difference, assuming it was scaled the same, would be the value of the slope, right? It was a steeper line for B2. 2 was a steeper line than 1, so it would have a larger slope, assuming they had the exact same scale. But they were both a positive slope there. Okay, so those are kind of what we're looking for. This means it's not moving. 0 velocity means no motion. This means it's moving in a positive direction. This means it's moving in the negative direction. That's it. Then when we start looking at the velocity, is it constant or is it changing? It's a straight line versus a curved line. If my slope, remember, well, that's something I put at the top. Remember, the slope gives us velocity. The slope of these types of graphs give us velocity. The slope of these graphs give us velocity. So if my slope is constant, straight line, then my velocity is constant. However, if my slope is changing because it's a curved line, then that means my velocity is changing. Curved lines in a position versus time graph mean or implies, tells us that the velocity of this object is changing. It's not the same. It's either speeding up or slowing down. It's one of the two. The fact that it's curved doesn't necessarily indicate one or the other. It's telling us that it is going to change. We have to figure that out. Now I drew some arrows. And the idea of the arrows is if my velocity is constant. Remember, our definition of acceleration yesterday was a change in velocity. So if my velocity is constant, my acceleration, the object is not accelerating. If my velocity is constant, if the object is not accelerating, which means my acceleration is equal to 0. Sometimes we say 0 or not 0 is sometimes how we can refer to this. So in this case, constant velocity, my acceleration is 0. So we could say A, acceleration, is equal to 0. Straight line, straight line. If it's going to be this, then it's always going to be this. If it's this, it's always going to be like this. Okay? I'll write it out, I don't know, sometime, that when we start looking at these types of motion problems, there's like this string of statements. And it's an if kind of then, or a kind of an equals. If my acceleration is 0, then my velocity is constant. The object is not accelerating. And the idea is if you get any one of those three, then the other ones are true, right? If my object is not accelerating, then my acceleration is 0, my velocity is constant. Straight line, straight line. Okay, and there's 3 different forms of a straight line. An object can have a velocity of 0, and not be accelerating, right? It starts at 0, it ends at 0, my velocity is constant, my acceleration is 0, my object wasn't moving and is still not moving. It never changed its velocity. So when we say acceleration is not equal to 0, mathematically, we can take an equal sign with put like a strike through it or a slash through it. That's another way to say acceleration is not equal 0. Velocity is changing, not equal to 0. Curved line, curved line. Lots of different options of curved lines. Okay, which means if my acceleration is not 0, my velocity is changing. It's either going to speed up or slow down, or change direction. For our motion graphs, we're going with the speed up, speed down. But realize, if we're talking like driving down the road, I can be moving at a constant speed. My acceleration is 0 right now, but now I'm accelerating because I turned, and now I'm not turning. Change in direction is also an acceleration because velocity is speed with the direction. By the way, my song that I played, that wonderful song, I got speed, that's how fast I'm moving, I got velocity. I purposely didn't point my camera at the screen. I still listened and said, hey, you got a copyright issue flag on my YouTube videos, but I can't make money on it now because copyrighted song, so not going to make any money on that video unless I trim out the song, but it's YouTube flag. But when we're going through and we say, hey, if my acceleration is 0, my velocity is constant, my object speed is going to stay the same. My velocity is constant, no acceleration, my speed stays the same. Those 3 statements are going to go together in like 1D motion problem, right? So if my object speed is the same, it's not accelerating, which means my velocity is constant. Those go together. This slowing down and speeding up one, this is one that it takes a little practice. And this is where yesterday I went and I drew some lines on our paper for these curved ones. So, did we do number 8 or number 9 together yesterday, you remember? I think we did 8. Did we do 8 together? I think we did 8. Okay, so in number 8, the first, I drew tangent line, was the black line. Then later, as time went on, so this is where my first time interval was, over here at T2, is going to be here. My line was steeper and it's getting flatter. Remember, what is this in terms of a slope?
0.
So what is this in terms of a velocity?
0.
Okay, so if it's getting closer to this, if it's getting closer to a velocity of 0, it's slowing down. Okay, so this is a slowing down curve. So it's, the way I described it in words, I'll switch it back, is my curved line is getting flatter as time goes on. Whereas in graph number 9, which I did with my 10th hour class, it started here and it went to here. For graph number 9, it's getting steeper. So it's getting further from, this is 0, so it's getting further from 0. This one's speeding up. Now this is curved like this, or this is curved like this. It doesn't matter which concavity they have. I always look at it, are they getting flatter or are they getting steeper? Okay, so there was 2 curves that were getting flatter. This one gets flatter as this is later in time, so as my time goes further, it's getting flatter and flatter. That's slowing down. This one is also getting flatter and flatter and flatter. So these are both slowing down. Where this one is getting steeper, and this one is also getting steeper. This one is moving in the positive or negative direction. Which one is this one? It's a positive direction or negative direction. What kind of slope is it? Positive or negative slope? Negative, right? So this has a, what kind of velocity then? Negative velocity, and this is, so this was going in the negative direction, and now it's slowing down. What might that look like? Right? I was moving in the negative direction and I slowed down. This one's moving in the positive direction and it's going slow. That's all that's shown. These curved lines are getting steeper, so this is also moving in the negative direction, but it's going faster and faster and faster, where this one is moving in the positive direction and it's getting steeper. Now these graphs, just so I'm going to be upfront with you, just stop, right? Like, hey, that's probably a velocity of 0. This object probably stopped. This object probably stopped. That doesn't always happen. This could be a parabola, which then it could start going back down. And then this half would be slowing down in the positive direction. And the other half of that parabola would look like this. And now it's moving in the negative direction and it's speeding up. And if we talk about something in the y direction, if we were to graph this ball, that's exactly what this ball would look like. The first half of the motion would be this, the second half would be this, right? Right? It's slowing down and then it speeds up. It slows down and then it speeds up. Moving in the positive direction is moving in the negative direction. It slows down in the positive until it stops, then it comes down in the negative and it speeds up because of gravity. Okay, so that's the idea. Now, if I were to give you a graph that looks something like that, I would want you to be able to describe the motion of that object, or of that graph. Okay, so let's start at the top. is the velocity of that graph 0, positive, or negative?
Positive.
Positive velocity. How do we know that? Positive slope is going upwards, right? What's the next one? Velocity constant or changing? Changing. Why? Because the line is curved. My slope is changing. This curved line's changing slope. Because my velocity is changing, is my acceleration 0 or not 0?
Not 0.
Not 0. It has some value. Okay, that's all it means. It's 1, it's 2, it's 3, it's -1, it's -2, it's -3, or some decimal. Speed the same, speeding up or slowing down? Slowing down, right? Because it's getting flatter. It's getting closer to 0. Now, we should probably have stopped it there because it actually tried to come back up. The same thing if we were to draw that. Positive, negative, or 0. Sorry, order was wrong. 0, positive or negative velocity. Positive. Constant or changing velocity. Because the curve is changing. Acceleration 0 or not 0. So is it accelerating or is it not accelerating then? It is, right? Okay. Changing velocity means it is accelerating. Speeding up or slowing down or staying the same? Speeding up because it's getting steeper. Okay. Questions on that? Okay. Then what I have next, last is your homework assignment, in-class assignment. Not sure, probably we'll finish, we'll see. It's a game. I found this game last year. It's called Motion Mapper, and the idea of this is, it works best on your iPad. So it's under today's in-person agenda. Motion Mapper. It's called Motion. Motion Mapper. There's an assignment link there. In there is a link that should get you directly to. There we go. Okay, so in the, is it published or not published?
No.
My bad. Oh, it's not?
This link isn't published.
What part's not working? Could you get today's agenda? Oh, that is it now?
Yes.
Sorry about that. I changed the layout of the course a little bit, and I hope you don't mind. I decided that I didn't like having a long list, so I'm going to make each week its own module. If you had me in the last year, that's what I did. Where the current week is going to be on the top. Okay, so that's what I'm going to do. So under today's agenda or under the assignment is called Motion Mapper. When you click on Motion Mapper, it loads this. I do want to show you that I have directions of what I want you to do. I want you to do the control mode of position versus time. We're only doing position versus time graphs. And I want you to do the input mode of position versus time graphs. Okay? I want you, so when you're done, there's this, you got to win the game. You got to get a 10 out of 10. Progress report, and then you type your name in it, and then enter, take a screenshot where that shows that you have a 10 out of 10 on the horizontal position versus time and control and input, and then submit the screenshot. Okay? The game is, I think, it's an okay game. The idea is you go through, and we are only doing the position versus time in the control mode and the input mode. And we're only going to do the horizontal axis. So the idea is you're trying to move that block such that it stays in that line. So for example, that green bar, I have to start at 8 meters and end at 8 meters. But partway through, it changes. So you gotta kind of drag the block around. So you gotta go, I failed. Okay? That's your input mode. I believe this is the input mode, okay? Okay. I got this, I got this. That wasn't good enough. Okay, you guys are gonna get this right away, but I'm not. There! Whew. Okay. Okay, and then, I don't know how to get out of this. And then, there, that worked. And then that's you're dragging your finger around for that one. And then for the other one, you're gonna go to input mode for it's still position versus time. And then you're gonna go input mode. Should be able to switch this input mode. Should be able to go to input mode. But that one, it's not working. That one you have to like look at your time intervals and it, like then there's velocities. So remember the slope gives you velocity. So you have to go through and do some slope calculation, rise over run, input mode. There we go, input mode. Position versus time, input mode. So now, for example, this is mine. I'm starting at 0 seconds at position number 8, and it ends at 4 seconds, and it goes from 8 to 0, so I have a rise of -8 for me, and it took 4 seconds, so my rise is -8 divided by a run of 4, my velocity then, for me, is going to be a -2, and I need to start that at time, right away at time 0. And then I do that. Now, if you notice, my line matches, except for a bounce, but I didn't have my position starting in the right spot. So I started at a position of 8, and then, okay, and once you get 10 out of 10 on both of these, it will show progress report. It will show right here, you click up on progress report, enter your name, make sure you enter your name, so otherwise you don't have your friend's screenshot. And this is all I need, you hit enter, you can't undo it once you hit enter. So that's my name, and then I'm just gonna look, does this say 10 out of 10? And does this say 10 out of 10? Okay. It kind of gets you, the intent is to kind of get you used to saying, hey, my change in velocity, I gotta drag my finger at a constant velocity, or I gotta change directions accordingly. Okay? So that's the game for you to play tomorrow. By tomorrow. It'll take a little bit, but that's the intent. Have a great day, everyone. We will see you tomorrow. I wonder if I remembered to hit record. I did. I'm gonna even